In this video, we're going to go over additional laws of exponents. Here are the ones that we know. If they have the same base and you're multiplying, then you add your exponents. If they have the same base and you're dividing, you subtract your exponents. Here is a new law of exponents. If the exponent is the same, then you can multiply or divide the bases. So let me say that again. If the exponent is the same, then you multiply or divide the bases. We're going to use the previous laws of exponents that we already know. The fact that if you're multiplying, you add your exponents, dividing, you subtract. And this new one right here to help us evaluate some expressions that have exponents. Example number one. In example number one, I need to see if the bases are the same or if the exponents are the same. In this example, my bases are the same. So if the bases are the same and I'm multiplying, then I need to add these exponents. 5 and a negative 3 added together is 2, and 2 to the second power is 4. Our next example. Again, I need to look and see if the bases are the same or if the exponents are the same. In this situation, the bases are the same. The bases are the same and I'm dividing. That means I need to subtract these exponents. So I write down the same base. I subtract these exponents, and I don't have to write an exponent of 1, and I simply get 5 when I evaluate this. My next example, I need to look and see if the bases are the same or if the exponents are the same. In this situation, the exponents are the same. That means I can multiply these bases together. That means I need to take 2, multiply it by 3, and I keep that exponent. 2 times 3 is 6. This is going to be 6 to the 4th power. So again, if the exponents are the same, then I can multiply or divide these numbers, whichever one it's telling me to do. Look at our next example. The bases aren't the same, but the exponents are the same. If the exponents are the same, then I can take my bases and either multiply or divide. In this situation, divide. 8 divided by 2 is 4, and then I keep the exponent. So we're going to evaluate these expressions using properties of exponents. If you're multiplying, you add your exponents if the bases are the same. If you're dividing, you subtract your exponents if the bases are the same. So I'll look, my bases are the same. Since my bases are the same, I keep that base and I subtract these exponents. 9 minus 7 is 2, and 4 raised to the second power is 16. I go to the next problem. The next problem, my bases are not the same, my exponents are the same, so this is really 3/4 squared. That's 3/4 times 3/4. 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. In this one, I have the same base, and I could write 3 to the 4th power, but they asked me to evaluate it. So I'm just going to go ahead and evaluate this. Sometimes these rules of exponents help me solve these, and sometimes they don't. This is a situation where it may not help me. What I'm really going to do is follow my order of operations. I'm going to do my exponents and then multiply. 3 squared is 9. 3 squared is 9, and 9 times 9 is 81. So sometimes these laws of exponents or these rules help make it simpler. Sometimes it doesn't. The bases are different in this example. The exponents are different, so none of those rules are going to help us on this. I just really need to follow my order of operations. I need to take 2 and raise it to the 3rd power. 2 raised to the 3rd power, is it 6 or 8? It's going to be 8. That's 2 times 2 times 2. 2 times 2 times 2. 2 times 2 is 4. And 4 times 2 is 8. 4 raised to the 2nd power is 16. Times 16 times 16. And 8 times 16, 128. 8. Next example. Are my bases the same? No. Are my exponents the same? No. So that means I just really need to follow my order of operations. Do my exponent first, right here. 4 to the second power is 16. I can't take 2 and divide it by 16. So this is a fraction that needs to be reduced. I need to find a number that will go into 2 and 16. And divide both of those numbers by that. That will be 2. 2 divided by 2 is 1. 16 divided by 2 is 8. I'm simply going to get a fraction as my answer on this one. Next example. My bases are the same. As soon as I see that my bases are the same, that means I can subtract these exponents because I'm dividing. So I write my base down and I subtract these exponents. -1 minus a -3. That's going to be 4 as my base, -1 plus 3 as my exponent. -1 plus 3 is 2, and 4 raised to the second power is 16. So my laws of exponents, or my rules, helped me solve this one. I look and see if my bases are the same or my exponents are the same. My bases are the same. Since my bases are the same, I write my base down, and since I'm multiplying, I'm going to add these exponents. 9 minus 8 is 1. I don't write 1s as an exponent. This is simply 7. I need to use some of my rules for exponents. I'm not supposed to have negative exponents. These certainly don't have the same bases, and they don't have the same exponents. What's my rule for negative exponents changing into a positive exponent? I rewrite this as a fraction. 6 times anything raised to the 0 power is 1. This needs to be flipped. 1/6 times 1. And what's 1/6 times 1? It's simply 1/6. I'll look and see if the bases are the same or if my exponents are the same. My bases are all the same. That means I can take all these exponents and add them together since I'm multiplying. -2 and 7 added together is +5. +5 and 4 added together is 1. I'm not supposed to write my 1s. This is simply 6. I look and see if my bases are the same. My bases are the same for these two, for this one and this one. So what I'm going to do is I'm going to resolve this negative exponent just like we did in this problem. 6 to the negative first power is 1/6 times 10. What can I do with these exponents? Since I have the same base and I'm multiplying, I can add them together and get -3. Just like changing this one around because I have a negative exponent, I can change this one around to where it has a positive exponent. 1/6 times 10 to the third power. That's 10 times 10 times 10. I'm going to have how many zeros in my answer? 3 zeros in my answer. 1, 2, 3. 6 times 1,000 is 6,000, and 1 times 1 is 1. Do I have the same base? No. Do I have the same exponent? No. I need to look at each one of these and see if I can do anything to help resolve this. This is simply going to be 4 to the third power. That's going to be 4 times 4 times 4. 10 raised to the 0 power is going to be 1. Again, 10 raised to the 0 power is 1. 4 times 4 is 16. 16 times 4 is 64. And then 64 divided by 1 is 64. Again, one of the first things I look for to see if we have the same base. We have the same base. So I'm going to use my rules of exponents when they have the same base. I'm going to write down my base. And then if I'm multiplying, what do I do with my exponents? I add those together. Remember, if I can't see an exponent, there's an exponent of 1 right there, and there's an exponent of 1 right there. 1 and negative 3 added together is negative 2. And negative 2 and 1 added together is negative 1. Since this says evaluate, I can't have negative exponents. I rewrite this as a fraction, and I flip this, and I get 1/9. First thing I look for to see if I have the same base. All these have the same bases, so I can use a lot of those rules for adding and subtracting my exponents. I'm going to keep this in the top, and I'm going to resolve this in the bottom. I'm going to write down my exponent, and I'm going to multiply these together. What do you do with your exponents when you multiply? You add these together. What exponent is right here that I can't see? A 1. A 1 and a negative 9 added together is negative 8. These have the same bases. What do you do with your exponents when you have the same base and you're dividing? I need to subtract these exponents. So I'll write down my base, negative 6 minus a negative 8. Negative 6 plus 8. And negative 6 plus 8 is 11 to the second power. 11 times 11 is 121. Next example. Again, I look and see if they all have the same base, and they all have the same base. That means I can use my rules. If I'm multiplying, I add my exponents. If I'm dividing, I subtract my exponents. I'm going to resolve everything in the top. I'm multiplying. That means I need to add all these exponents together. 9 and 5, I add those together, and I get 14. 14 minus 5. 14 minus 5, I'm right back to 9. What exponent is right here that I can't see? There's a 1 right there. What are you supposed to do with your exponents? When you divide, you're supposed to subtract. This is 5 to the 8th power. Now sometimes when you get really big numbers, it's easier to leave it as an exponent, and they may ask you to leave it as, it may be okay to leave it with an exponent, since this is going to be a really big number, because this is going to be 5 times 5 times 5, all the way 8 times. Again, I look and see if I have anything that has the exact same base. This right here has the exact same base. These do not have the same bases or the same exponents. So I'm going to go down, and I'm going to resolve as much as I can using some of these rules. Like this. 3 to the second power is 9. 5 to the negative first power. I'm going to take these two right here. I'm going to write down the base in the top. And what are you supposed to do with these numbers when you're dividing? Subtract. That's going to be negative 5 minus a negative 6. 9 times 2, 5 to the negative first power. This is going to be negative 5 plus 6. 9 times 2, because negative 5 plus 6 is 1. Don't have to write that exponent of 1. 5 to the negative first power. Again, what are you supposed to do with negative exponents? I'm going to take this negative exponent, I'm going to flip it, but that's the only thing that gets flipped, is the base with the negative exponent. So this is 5 times 9 times 2. 5 times 9 is 45, and 45 times 2 is 90.